Okay, Assalamu alaikum, Shabab. Welcome back to the class. Before we start the class, I would like to announce that the grades for the quiz number 4 are already updated in the Blackboard. There is only one thing now which I need to figure out, how to return back the quiz to you. Because this time was the first time when I asked you to submit the solution as actually like an assignment. And it made it so easy for me to grade this with my pencil and tablet very easily, like if I have collected your quiz sheets. My problem now is that how do I return them to you? So I'll try to figure out an easy way, probably even before we do the quiz on Thursday, because if it turns out to be difficult and time consuming, maybe I have to do other way. Because unfortunately, the Blackboard grading, method system is very, very bad. It wasn't easy for me to grade your homework, your quizzes in the past. So actually the midterm. So we'll figure that out. For now, you can know your grade out of 18. I have to make another announcement regarding quizzes. There are some students who seem to be doing something. I would not say it is cheating, but students who have multiple attempts, students who are based on the Blackboard supposed to solve a problem with a given diameter, given load. And because, as I told you, everyone has different, nearly, everyone has a different values. There is some indication now that tells me that some students probably might have a problem with the internet. This is why they get in and get out, and then get in again. But there might be a chance that some of you are trying to get in, and maybe they are coordinating with somebody else, and if they don't have the same numbers, they get out, one of them get out and get in, get out, get in, and Blackboard will still randomize your chances until you get the same values, and then you solve it together. Of course, this is just a fake story I'm telling you, but I am afraid that some of you might try to do this, because I don't have any explanation when the entire class are, just doing great. Everybody is attempting once, and there are a few who are not. So it is either the internet connection with those, or they are intentionally doing it. And I have realized that some students keep having the same issues. And I don't know, is it the internet or is it intentional? So just to make sure that we run this fairly, I need to regulate it. And in order to regulate it, next time in the quiz, you will have one single attempt. And anybody who had a problem will have to tell me. I can't just give you unlimited number of attempts and let you keep trying. I have to admit you to do that. So just watch out next time. Yes, يا صالح.
دكتور اذكر واحد من الدكاتره كان عنده طريقه معينه بحيث انه اذا دخلت الاتم الثاني تجي لك نفس الارقام دكتور.
I tried and I was trying to get that, but there is I will dig it out. But as far as I know, we need to feed Blackboard with many varieties, and then it will randomly assign one to each student. We'll see that, okay?
Thank you.
But just be careful next time, okay? Now, do I have anything to say? No. That's it. So let me now go to the solution of this frustum problem, or frusta, if you want to say. So if you recall, last class, we of the washer, and from the thickness before, okay, there's a little bit of delay. Now, you will see that what did we do? We put first plate, the second plate, and the washer, add them together, and we get the entire length of the grip. Okay, this is actually, this one, all of it is actually L, small L. But if we divide it by 2, if we divide L by 2, we'll get half of the distance. And what did happen is this: we have half of the grip right here. Do you see it? Now, this half of the grip shows us that we have, now remember, this one is gray cast iron. This one is steel, and this one is steel. So the above, the one on top, frustum, can be analyzed as one steel, and the one below can be analyzed as a cast iron. But if we really focus on this, we'll see that this is the end of the steel. So we will be forced to take this as one frustum, the steel plate and the washer, one piece. And then what will happen? So if I draw, this is the first one. The second one, which is entirely made from cast iron, okay, takes the shape like this. So since we developed the equation for a frustum, and a frustum definition is that it is a cone with the peak of it being cut off. So this is not a frustum. This is not. So what do? We are forced to split the one on the bottom to 2 pieces. This is number 1, and this one is number 2. Why? The top one now is one frustum, the below one is one frustum. Although they are both made from the same material, cast iron. So we'll have this one as number 1, we will have this one as number 2, and we will have this one as number 3. Any question, ya shabab? Okay, no questions. So let's move on now and try to calculate the stiffness of the first one. Okay, so the first frustum, if you, I hope you can recall the number. I'll try to draw it now for you. What do we have? We have something like this. And we know that this distance is a small d. We know that this distance is capital D. And we know that this entire thickness is T. Okay, good. Now, what is T, ya shabab? In reality, T is the thickness of the washer and the thickness of the second plate. So that's the first plate. This one is 0.5 inches, and this one is 0.095. So the thickness is 0.595 inches. Done. What is the small diameter? The small diameter is 0.5 inches. It's given to us. We said that it is half. What was the name of the bolt, ya shabab? I forgot it. It was as given in the problem. It was half inch, 20 UNF, and so on and so on. So it is half inch in small as a nominal diameter. And then we have the capital D. Now, what is the capital D? This is just below the head of the bolt. We said that the head of the bolt has a hexagonal shape and the nut has a hexagonal shape. Both of them should be matching. So we went to the table and we realized that for a hexagonal nut, corresponding to a nominal diameter of ½ inch, the width is 3/4. So that's why we decided that this is 0.75. Now, this 0.75 is going to be our big D. So this is 0.75 inches. Now, if we write down the equation for K1, it's a big one, of course, assuming that alpha is 30, which is usually the case. We will have 0.577 by, and then ED, and then len, the natural logarithm of 1.155t plus d minus small d multiplied by capital D plus small d divided by 1.155t plus d plus small d multiplied by capital D minus small d. Okay? Now, if you look at this equation, the modulus of elasticity for steel in BSI is 30 multiplied by 10 to the power 6 BSI. Good? What is the small diameter? Is 0.5 inches. What is the big diameter? It's 0.75 inches. What is the thickness? It's 0.595 inches. That's it. You plug, those are all the numbers. You plug them now. I want to inform you or warn you about something. You want to go and solve this. Just bunch the calculator exactly the same way. At least, because you may trust that you will do this right, but believe me, there is a good chance you will do it wrong. You will get a wrong answer. So be careful. Usually, whenever we have an equation like this, there is a division with logarithmic, and you know, it gets really tough for students. So if we solve all of this, plug the numbers, we will get the K1 as 30.8 multiplied by 10 to the power 6. Now, what is the unit? It's like a stiffness. We call this stiffness. So it's like a force per length. So it is bound force per inch. And in Newton, it's going to be Newton per meter. That's the stiffness. Any question, ya shabab? Okay, no questions. Let's go to the other one. Now, the other one, in reality, ya shabab, if you look at your slide number 48, you will see that in reality, there is a big frustum like this, and there is a smaller one below it. We are after the small one. Now, this is number one. We have done it. We finished from it. This is number two. Now, we know that the distance from here to there, to the bottom, is the half of the grip. That distance was measured as 0.6725 inches. We know that. And we know that the distance from here to there is how much? 0.595. So if we subtract them, we will be able to know what is the thickness of this small frustum, which is frustum number 2. Its thickness is going to be 0.0 and then 775 inches. Now, you know, we need the thickness, we need small d, we need capital D, and what? And we need E. Is that right? So the first one is 0.0775 inches. Then small d, well, doesn't change. The small diameter is still the same as the diameter of the bolt. Now, what is capital D? That's the question. Why? Because E for cast iron in BSI is actually 14.5 multiplied by 10 to the power 6 PSI. So that is not difficult. But now we have a problem here. We don't know what is the small diameter, which is this. Okay, this is usually, when this case comes, you need to be very careful because it needs a little bit of a calculation. So let's analyze it nicely. And now let me draw the frustum like this. Just forget about the hole inside, okay? Now, if you look at this, okay? If you look at this, you will see that this is 0.75, which is the width of the what? The width of the nut, the hexagonal head of the bolt, which is the same as the width of the nut. Okay. Now, if you draw a perpendicular line, you will know that this part is also what? 0.75, reasonably. Now, let me draw the green line indicating that frustum number 2. There it is. Now, what do you see? You can see that this is 0.75, and all what I need to do is to find this and this, which by symmetry, they're supposed to be the same. Now, question number 1. What is this length? What is it, ya shabab? This one is 0.595. Is that true? Is it true? This is the length over there. I know it. And I know that this angle is 30. I use the equation, which is made by assuming that alpha is 30. So that's it. So in this case, I will have a triangle. Now, what is missing here? This distance, I'm gonna call it x. This one is supposed to be x as well. So there is x, this is angle 30, and this is distance 0.595 inches. Good. So what is x? Tan 30 equals to x divided by 0.595, which means that x is equals to 0.595 multiplied by tan 30. So what do I do? The diameter, big D, is equal to 2 x's. 2 multiplied by 0.595 tan 30. And don't be happy, ya shabab, that, whoa, I found it. And then you forget to add the 0.75. What a shame. So this is 0.75. And that's it. You do that, you will be able to substitute all the numbers, and you will get K2 as 285.5 multiplied by 10 to the power 6 pound force per inch. Any question, ya shabab? All right, no question. So let's move on to the bottom one, which is the last one. Now, the last one is an inverted frustum like this. Let me draw it as nice as I can. And what is its thickness? We need to know it. What is E? E is still cast iron. What is a small d? And what is capital D? This is capital D. Now, for the thickness, ya shabab, for the thickness, it is basically half of the grip. Go back to slide number 48, you will see that that frustum is actually have a thickness which is the same as 0.6725 inches. What is E? E is 14.5 multiplied by 10 to the power 6 psi, which is the modulus of elasticity for cast iron. What is a small d? It is still 0.5 inches. And what is capital D? 0.75 inches. Now, because it's at the bottom there is the nut, and the nut has the width of 0.75. Again, you plug the numbers, and what do you get? You get a value of K3, which is equal to 14.15 multiplied by 10 to the power 6. Sorry, not psi. Pound force per inch. Good. So now I can say that 1 over Km is equal to 1 over K1 plus 1 over K2 plus 1 over K3. And if I do so, I will get, ya shabab, I will get a result of Km is equal to 9.378 multiplied by 10 to the power 6 pound force per inch. Okay, ya akhwan. Yes.
Doctor, if we have the same material of the all over the thruster, how can we find D,
Yeah.
capital D?
Well, if this is what I was planning to talk about, if we have, which is the question is asking about, if we have everything made up from the same material, which means the washer, the first plate, and the second plate, all of them made from the same material, E, which is in this case steel. Then, if you go to slide number 44, which is equation 25, it will tell you that Km right away is calculated from the equation, which is 0.5774 by ED divided by 2 len, and then you have a constant 5 multiplied by 0.5774 L plus 0.5 small d, and then we have 0.5774 L, and then we have plus 2.5 d. And if you look at this equation, this is the modulus of elasticity. If it is a steel, it is 30 multiplied by 10 to the power 6 psi. Small d is 0.5 inches. What is L? What is L? L is the entire length of the grip. L is equals to 0.095 plus 0.5 plus 0.75. Do you understand that? There is no D, capital D. You don't need it. So if you do this, in this example, if you do this, you will find that Km, if you assume it to be steel, then Km is going to be 14.64 multiplied by 10 to the power 6 pound force per inch. This is what the question is asking about. Then the question is asking you, how about if you use the equation Km over ED, which is equals to A exponent of BD divided by L. Now, if you look here, L is the same as this one, the sum of everything. D is 0.5 and E is known and the diameter is known. What we are left with is A and B. So as described in the solution, if you go to table 8.8, okay, you will find A for a grip which is made up entirely of steel. Of course, table 8.8 has a limited condition, but if you use this equation, you will realize that this is now the stiffness using the frustum method. And if you use the equation, you will get Km, which is equal to how much? It was 14.92 multiplied by 10 to the power 6 pound force inch. So the difference is not a lot. If you compare it, the difference is not a lot, but it's actually very nice. Solving this exponential equation is actually easier than the other one. So you might use it, but as I said, first, you might be asked in the quiz or in the exam about finding the stiffness of the member, which is entirely made up of the same material. And the solution might be available for this equation and table 8.8. But if the question is saying, use the frustum method, then you should use it. Now, behind the scene, after solving the frustum method, you might be willing to go and use this equation quickly, because you may solve this equation in 30 seconds and see if the numbers are good. Just in case, to make sure that you did not bunch wrong numbers in this big equation. Do you understand? طبعا الخطأ اللي الطلاب يقعوا فيه هنا وشه أو المعادلة هذه بالذات هذه الكبيرة إنه هو يبقى يضغط الأرقام كلها مع بعض في نفس الوقت. While I don't advise you to do this, go calculate this, put a note, calculate this, put a note, calculate this, put a note, then divide these, put a note, and then put this over there. This way you will be okay. Okay, good job. All right. Now, what is the question is asking us to do? Yes, yeah, Salman.
Yes, Doctor, what if the diameter of the washer was not 1.5 the diameter of the bolt? Can I still use the last equation?
Yes, it is. It says in the book that this is the general case, and unless otherwise stated, then you shouldn't have any problem. طبعا خلينا نفترض يعني إنه أنت you are designing something and this something is very dangerous, and you did assumption or you actually end up using a washer which is different for a special condition. Don't feel any problem. Instead of making your life easy, but you feel risky by using this equation, go and spend time and use this equation. I know you will split them into frustum, and then you will add them, and then it will be long, but this has only one assumption in it, which is the fact that the alpha is 30. Okay, Shabab. So don't worry, as far as here, this course, that assumption is still valid. Yes, yeah, Abdurrahman.
دكتور ممكن تروح على سلايد 55. لا اللي كنا نحلها قبل شوي اللي
55. Do I have a different slide from you? Okay. 55. Okay, here, yes.
Why we use the small t here, the 0.595 to find the x? Why we did not get the full t, which 0.6725?
Yeah, if you use 0.625, it means you found this. This is longer,
Yes.
right? Longer by a little bit. We don't want the bottom one, we want the top one.
We always take the
Good.
Smallest one or what?
Well, no. The rule is this. If you have a frustum الفرستم as a shape its definition إنه في small diameter في big diameter. This one, this is big, this is small, and it has a thickness. This is our assumption. In the equation, the diameter is defined on the small one, not on the big D. Big D is defined here, not the bottom.
Oh, okay.
So why should I calculate this? I don't need to.
Okay. Thank you.
I'm talking about this. I don't need to calculate this one in the bottom. The arrow will appear. I need to calculate this one in the top. Okay.
Okay.
All right, good. Now, the second and last part of this question is asking about the stiffness of the bolt, which is very reasonable. We will tell you, inshallah, next class that, as I mentioned earlier, that the stiffness of the bolt and the stiffness of the member, both of them will make up a parameter which is called C, or a coefficient called C, which will indicate the strength and so on. So the stiffness of the bolt, the equation KB is equal to AD, AT multiplied by E, divided by AD multiplied by LT, okay, plus AT multiplied by LD. Now, let's go over this together. First of all, what is AD? AD is equals to pi over 4 multiplied by D square, where D is 0.5. There is no question about this. It's very straightforward. Now, what is E? All bolts in this textbook are made from steel. So this is 30 multiplied by 10 to the power 6 BSI. وش بقى؟ بقى 80. Do you remember what is 80 يا شباب? Anyone?
From the tables?
Yes. 80 is the tensile stress area. What do? You go for the table that shows the bolts for inches, which is table, which one? Let me see. Table 8.2. So you go table 8.2, and then you go for diameter equals to 1/2. And don't forget that you should use UNF, the fine threading. You will find 20 as the number of thread per inch, but your main goal is to find 80. And if you do this, you will find that 80 is equals to 0.1599 inches square. Good. Now, if you open the slide right now and you go back to slide between 38, 39, and 40. If you go to slide 40, you will find that LD is equal, the length of the unthreaded portion within the grip. It is equal to capital L minus capital LT. Now, if you go back to the name of the bolt, if you remember, when we discussed it, we said that this part, 1/1.5 inch is the length of the bolt. So that's capital L. This one is capital L. Now, this is 1.5. Now, if you so remember that this is now 1.5 inch. Now, what is LT? Now, if you go to slide number 39, it will tell you that if L is less than or equal to 6 inches, then LT is equal to twice as the diameter plus 1/4 inches. So we will have 2 multiplied by half plus 0.25. So 2 multiplied by half is 1. and then plus 0.25, so you will get LT as 1.25 inches. خلصنا. Now, what do you have? You will have 1.5 minus 1.25, so LD will become 0.25 inches. Now, what is small LT, which is the length of the threaded portion inside the grip? Okay, it is equal to L, the length of the entire grip. Do you remember what is the length of the entire grip? The length of the entire grip is 0.095 plus 0.5 plus 0.75. That's the between the head and the nut. Minus LD. LD, we just calculated it. So when you plug all of these numbers, you will find that KB, let me find it from here. So you'll find that KB will be equal to 3.69 multiplied by 10 to the power 6 pound force per inch. Good. Any question? This idea of finding the length is very important. You may, ya shabab, let me just give you one thing, an example. If I tell you that there is a problem where we have a washer, and then we have a plate, and then we have a big plate, and then we have another washer. Now, and I told you that we are using a nut, let's say whatever the size of the nut. Now, if you go to the standard, you will find that the size of the nut has a width and it has a height. So if I tell you that what's supposed to be the length of the bolt here? The bolt will have a head, no doubt about it. الهيد حق البولت هذا راح يكون نفس الهيد حق النات. The same. الوidth نفسه. They are symmetric. But now, how long is this bolt? The length of the bolt starts from here all the way down. Now, what did we say before? We said that we should logically, ما معقول إنه يكون أصغر. So, if I call this one thickness 1, thickness 2, thickness 3, and this one, for the sake of generality, this is thickness 4, then the length of the bolt should be approximately, equal to T1 plus T2 plus T3 plus T4 plus H plus what? 2 threads. 2 threads. That's what this one has to be decided as the entire length of the bolt, at least 2 threads. So if you have it in millimeter, we told you that in millimeter we have the pitch size, which is the size between 2 peaks. So if this is P and you have 2, so you have 2 of B's. So you have to say 2 P's. Do you understand that? At least. So that's, maybe 3 maximum. But we told you that the standard has to go like that. So what did I do, ya shabab? In here, this is the solution that we talked about. And then this is something we are not going to discuss together, but I am just going to explain it to you. The reason behind this problem is to give you a question on the bolt, frustum, stiffness, everything, but in metric system. So here you have a bolt size, which is M stand for metric, and then 14. 14 stand for the nominal diameter in millimeter. And this is the pitch. So what do you need to do is that you will see that also the convention, this is 14R. 14R means a plain washer and it is 14 that fits this size. So this washer will have basically a hole in it because its shape is like this. This is the shape of the washer, which has 14. لأنه مو معقول يا شباب. The bolt has to pass through the washer. So the whole purpose of this example is to give you this exercise. Everything here is in millimeter. I want to remind you that, as I said, you will find that stiffnesses like KB or KM are measured here in meganewton per meter, or 10 to the power 6 Newton meter. Newton is a force, and then meter is a length. Do you understand? Over this exercise, and it will teach you, inshallah, a lot about, this is table A31 for hexagonal nuts. And this is for plain washers, okay, metric. So the last thing that we want to talk about, طبعا يا شباب, if you, just before we move on, you need to understand that having the book is always trouble for students in this course. And because they always think that, oh, since I have a book, then I'm fine. But you need to practice. You need to solve the problem by yourself at least once. Otherwise, you will find yourself getting silly mistakes. That's number one. Number two, finding solutions that are imaginary. Like some student, I remember some student made mistakes. They started getting stiffness by thousands of gauges. Do you understand? It doesn't make sense. What is this material? From where did you get it? So you have to feel the numbers. That's why you need to practice. Now, the last thing that we want to talk about in this lecture, and then we will stop, is the strength of the bolt. Now, we determined the stiffness of the bolt. Now, just imagine with me the equation which says that F is equals to K multiplied by X. The famous equation for a spring being subjected to a force being extended distance X. Now, we just found this KB, and now we will be somehow able to find the stresses in the bolt. If we know the forces, we can know the stresses. Remember, we know the stress, the tensile stress area. So, question is this: how do we make bolts, by the way? If you go to machine shop and tell them, I want to machine a bolt, now what are they going to do? They will bring a round piece, and then they will cut it like this, which is a uniform diameter. And then they will bring a cutting tool. They will feed the tool forward, and then they will move it in the transverse direction. Now, as they move it, you will get the thread machined. Okay? Now, before you machine the thread, if you look at this material, this is a steel. It might be a steel, maybe. This is not true, but maybe it's steel 1050, hot rolled. Why not? Maybe. You can do that. And then you converted it into a bolt. The question is, when you have this, you know SY and you know SUT. صح ولا لا? You take any specimen from 1050 steel, you pull it, you get the conventional stress strain curve, where here we have SY and here we have SUT. So the question is this: if we just imagine with me, if we made a sample for tensile test, but in the gauge we introduce a thread, and then we build it, and we recorded the force, and then we divided this force by the tensile stress area, we will get a stress when this one breaks down. that stress is where? Where? Is it here? Is it here? Is it here? Is it here? Or is it here? Where? Where is that stress? Now, it turns out that it was a unique stress. It is not the yield. It is not the ultimate, and is actually called a proof strength. So F was FP. It's called proof force. The proof force is the force. If we divide it by the tensile stress area, it will give us a stress, which we will call proof stress, SP, which correspond to the load that initiate failure in the bolt. Now, it turns out that SP is actually less than the ultimate and the yield. So if this is the curve, SP will be here, SY will be here, and SUT will be there. So this is a new thing. Instead of talking about yield and ultimate, okay, we will mostly talk about proof strength when we deal with bolted members, okay? Mean bolts, threaded members, okay? I think I will stop here. This is good enough. And this is where I stop with the other lecture. For now, I am going to ask you to switch on your webcam, and I'm going to take that in this. Okay, Hussein?
Yes.
Okay, Saleh, Said? Saleh? Adnan? Muhammad?
Yes, Dr. Here.
Saleh
Yes,
Sultan?
doctor. Yes.
Ali?
Yes, doctor.
Walid Al-Amri?
Yes.
Faisal?
Yes, doctor.
Ali?
Yes, doctor.
Muhammad Abos?
Yes, doctor.
Muflih? I think I saw him. Where are you, Muflih? Muflih, where are you? Okay. Fahad?
موجود.
Faisal?
Yes, doctor.
مصلح?
دكتور.
Salman?
Yes.
Faris?
Yes, doctor.
Also here. Khalid?
Yes, doctor.
Saad?
Yes, doctor, here.
Umar?
Yes, I'm here.
Tamer?
Yes.
Mustafa?
Yes, doctor.
Fawaz?
Yes, doctor.
Amjad?
Yes, here.
Faisal?
Yes, doctor.
Muhammad? Okay. Nasser?
Yes, doctor.
Abdurrahman?
Yes, present.
Umar?
موجود.
Muhammad? Muhammad, where are you? Muayyad?
Yes, doctor.
Muhammad?
Yes, doctor.
Okay, that's it يا شباب. Thank you so much.
دكتور انا من السكشن الثاني يا دكتور.